Right now, at this exact moment, your car is lying to you. Not metaphorically, not poetically. Your vehicle's climate control computer is staging a performance, a theater of mechanical failure so convincing, so perfectly engineered to mimic catastrophic breakdown that trained mechanics at dealerships across the country have built entire revenue departments around it. If you have ever turned on your car's air conditioning and felt one side of the cabin blow freezing cold air while the other side pushed out air as warm as a summer afternoon, or if you have ever heard that horrifying, rapid-fire clicking sound buried deep inside your dashboard, the sound that starts quietly and then grows louder and more panicked over the course of a few days, then the industry has already identified you as a customer. They have already tagged you as someone who does not know what I am about to tell you. And what I am about to tell you will cost them thousands of dollars the moment you finish watching this. The repair quote you are going to receive, or the one you may have already received, is going to be somewhere between $1,200 and $2,000. The service advisor is going to use words like failed actuator and internal gear damage and labor-intensive dashboard removal. They are going to describe a procedure that takes a technician 8 to 10 hours. They are going to tell you that the tiny electric motors behind your dashboard have physically destroyed themselves, that the plastic gears inside have stripped or shattered, and that the only path forward involves pulling apart the entire interior of your vehicle. And almost every single time, that diagnosis is completely and deliberately wrong, not mistaken. Wrong. There is a sequence of button presses on your existing climate control panel that costs you nothing, takes 60 seconds to perform in your driveway, and resets the entire system to factory calibration. Engineers who design these systems put it there on purpose. The dealership service manual contains it. And it has been quietly, systematically withheld from the owner's manual you were handed on the day you drove your car home. To understand why this hidden reset exists and why it works so perfectly, you have to go back to the early 2000s. Before roughly 2002 or 2003, the heater core and air conditioning blend doors in most vehicles were controlled by simple mechanical cables. You turned a dial, the cable pulled, and a physical plastic flap inside the HVAC box rotated, blending warm air from the heater core with cold air from the evaporator coil in direct proportion to where you set the dial. The system had zero electronics, zero memory, and zero ability to fail in the way modern systems fail. It was dumb in the most brilliant way possible. It could not forget anything because it was not storing anything. The position of the blend door was always exactly where the cable physically placed it. Full stop. Then, the automotive industry made a decision that was sold to consumers as luxury and precision, but was quietly celebrated in boardrooms for an entirely different reason. Engineers transitioned to fully electronic dual-zone climate control. Instead of a mechanical cable pulling a flap, a small electric stepper motor, about the size of a pack of cards, was bolted onto the side of the HVAC housing. This actuator contained a set of tiny plastic gears and a small feedback sensor. The car's climate control module would send electrical signals to the motor, telling it to rotate a specific number of steps in a specific direction, and the motor would move the blend door accordingly. The system was genuinely clever engineering. It allowed both the driver and passenger to independently set different temperatures. It allowed the computer to automatically adjust airflow based on sun load sensors and ambient temperature readings. It was a genuine improvement in comfort. But here is where the engineering beauty collides with a deeply inconvenient physical reality. That small stepper motor does not operate on absolute position. It cannot look at the blend door and know where it is, the way you can look at a clock and know the time. It operates on a relative count. 2. When you first start your car and initialize the climate system, the computer tells the actuator motor to sweep all the way to its mechanical stop on one end, the point where the door physically cannot move any further. That hard stop is registered in the computer's memory as position 0. From that 0 point, the computer counts every individual step the motor takes as it moves the door. If the door needs to be at 50%, the computer tells the motor to take a specific number of steps away from 0 and then stop. The computer maintains this count in a small section of volatile memory, a memory that requires a continuous, stable supply of electrical power to hold its data. Here is where your $1,200 repair bill is born. When the voltage in your car's electrical system drops, even briefly, even for a fraction of a second, that volatile memory can lose its reference point. This happens more often than you would ever believe. It happens when your battery is slightly cold on a winter morning. It happens when a high-draw accessory like a rear window defroster pulls the system voltage down momentarily. It happens after a stereo installation, or a battery replacement, or even a long period of the vehicle sitting parked without being started. The computer does not lose all of its programming. It loses the single most important piece of spatial data that the actuator system depends on. It forgets where 0 is. Now, think about what that means mechanically. The computer believes the blend door is at 50%. In reality, because the reference point has drifted, the door might be pressed hard against one of its mechanical stops, fully open or fully closed to heat, and the motor is still trying to drive it further. The gears are jamming against a physical barrier. The motor is receiving a command it cannot execute, and so it tries and fails and tries and fails in rapid mechanical succession. That clicking sound you hear, the one that sends a cold wave of dread through your chest the first time you notice it on a Monday morning commute, is not a broken actuator. It is a perfectly functional actuator receiving instructions from a computer that has lost its map. The actuator has not failed. The computer is simply trying to drive to an address that no longer exists in its navigation system. The reason this is so magnificently profitable for the repair industry requires you to think about incentives for just a moment. When a mechanic diagnoses a clicking blend door, they have two choices. The first choice is to spend 60 seconds performing a system recalibration reset that restores the computer's memory of the zero position, costs the customer nothing, and sends them home happy with no invoice. The second choice is to quote 8 to 10 hours of labor to remove the dashboard, unbolt the HVAC box, extract the actuator, replace it with a $40 part from the parts counter, reassemble everything, and charge $1,400 for the privilege. One of those choices generates $40 in parts revenue and perhaps zero labor charge because most ethical shops would not bill for a 60-second procedure. The other choice generates over $1,000 in pure profit. The industry did not arrive at this situation by accident. It was cultivated, maintained, and protected. When automotive engineers designed the electronic climate control architecture in the early 2000s, they knew the calibration drift problem would occur. They knew because they had tested these systems in temperature chambers, they had run them through battery drain scenarios, and they had watched exactly this failure mode appear in their data. So, they built a solution directly into the software. A forced recalibration routine. A function that, when triggered by a specific sequence of inputs from the driver, commands the climate control module to completely discard its current position memory, drive every actuator motor to its hard mechanical stop, re-register that stop as absolute zero, and then perform a full sweep of every blend door's range of motion to rebuild an accurate internal map of the system's physical geometry. The entire process takes less than 60 seconds. The motors sweep, the system flashes its indicator lights to confirm the process is running, and when it finishes, the computer has a fresh, accurate, factory-calibrated understanding of exactly where every single airflow door is positioned. This recalibration routine appears in factory service documentation. It is listed in the technical service bulletins that manufacturers distribute to dealership service departments. It is not a secret to the technicians performing the diagnosis. It is a secret to you. And keeping it a secret to you is worth billions of dollars per year across the repair industry as a whole. Now let me give you the procedure and the exact detail you need to actually use it today. The specific button sequence varies slightly across manufacturers and model years, but the underlying logic is identical across nearly all electronic dual-zone climate systems produced since 2002, covering the vast majority of General Motors, Ford, Chrysler, Honda, Toyota, Hyundai, Kia, and Nissan vehicles built in the last 2 decades. Start by parking your vehicle and turning the ignition to the on position without starting the engine. You want the electrical systems alive and the dashboard illuminated, but the engine itself must not be running. This is critical because a running engine introduces slight voltage fluctuations from the alternator that can interfere with the calibration sweep. Once the ignition is on and the climate control display is illuminated, reach over to your fan speed control and turn the fan completely off, not to the lowest setting, fully off. The system needs to be in a low activity state to accept the recalibration command. Now, simultaneously press and hold both the defrost button and the recirculate button at the same time. On most vehicles, these are physical buttons located directly on the climate control panel. Hold them together for a continuous count of 5 to 10 seconds without releasing either one. Do not tap them. Do not press one before the other. Press them simultaneously and hold the pressure steady. Sometime between the 5 and 10 second mark, you will see the climate control display, lights flash, blink, or cycle through a brief sequence. On some vehicles, the entire panel briefly goes dark and then reactivates. On others, the fan speed indicator lights will cycle from low to high and back down again. This flash or blink is the system confirming that it has received the recalibration command and is initiating the sweep routine. Immediately after you see the lights flash, release both buttons and sit still. Do not touch anything on the climate control panel for the next 45 to 60 seconds. Behind your dashboard, you will hear the actuator motors begin to move. You may hear a soft mechanical sound, a gentle whirring or cycling, as each blend door motor drives to its end stop and registers its zero position. This is not damage. This is the system doing exactly what it was designed to do. The motors are remapping themselves. The computer is rebuilding its spatial knowledge of the entire airflow system from scratch. When the process is complete, the display will return to normal operation mode. Turn the fan back on, set your temperature, and test both sides of the cabin. In the vast majority of cases, the clicking is gone. The uneven temperatures are corrected. The system behaves exactly as it did when the vehicle was new. No parts were replaced, no dashboard was removed, no technician spent 8 hours on a lift. A voltage drop caused a calibration drift. A 60-second software reset corrected the calibration drift, and the problem is resolved permanently until the next time a voltage event causes the drift to reoccur, at which point you perform the reset again for free from your own driveway. Commercial fleet operators have known about this for years. Municipal transit authorities that operate hundreds of vehicles and track maintenance costs with analytical precision have formal written protocols instructing drivers and fleet managers to perform this exact reset before any HVAC work. Order is submitted for parts or labor. Internal studies conducted by fleet management consultants have consistently shown that between 70 and 90% of blend door actuator replacement work orders on electronically controlled climate systems are preceded by no attempt at software recalibration whatsoever. The parts are replaced, the dollars are collected, and a free solution was available the entire time. This is not an isolated incident of one dishonest shop. This is a structural feature of how automotive service revenue is organized. The complexity of modern vehicles has been used as a moat, a barrier of intimidating technical language and physical inaccessibility that separates you from information that is rightfully yours. You paid for the vehicle. You paid for the climate system. The engineers who designed that system gave you a self-healing protocol as a gift, built it into the hardware you already own, and the industry intercepted that gift and turned it into a revenue stream. Share this video with every person you know who drives a car. Do not think of it as sharing content. Think of it as handing someone the specific tool they need to refuse a fraudulent invoice. The dealership model depends on your ignorance staying intact. Every view this video gets is a dollar they will never collect. Every person who learns this reset is a customer permanently lost to a repair job that should never have been sold. Before you go, here is something that is going to stop you cold when you hear it. The same exact suppression playbook used on blend door actuators has been deployed against a completely different system in your vehicle, one that the industry generates even more money from because the failure mode is invisible, the part is more expensive, and the free fix requires knowing a single 3-digit number buried in your car's onboard diagnostic menu. The transmission system that every dealership in the country will tell you needs a full fluid flush and a pressure test when it starts hesitating between second and third gear. The real fix? A hidden adaptive reset that costs nothing and teaches the transmission computer to relearn your specific driving pattern from scratch. That is the next video. Make sure you are there for it, because that one is going to be even more expensive for them than this one.